Okay, cool. I'm just checking if we have audio here. Let's see. Does it work? Okay, cool. I'm just. Could you say something, Ives?
Hey, hello.
Go here. Let's see. Does it work? Okay, cool. Could you say something, Ives?
Hey.
Okay, this is great. Yeah, now we have like this will work every time now. I think this is super nice. Okay, rest. So why, Ives, are we learning Rust?
Oh boy. Okay, fifth time I'm giving this pitch, I think. You can write very performant code without risking memory issues, unsafe memory issues, security issues, because Rust doesn't run a garbage collector, which is great. Makes it closer to C++. However, with C++, human mistakes are made from time to time, where sometimes invalid memory is still referenced. And the semantics of Rust are really interesting because you write in the language with memory safety in mind. That's just one of the things I really like. The other thing I really like is the trait system, but that's something that is harder to describe in just a single line. But I find it really cool in Rust that it gives you this amount of performance with small chance of with no chance of human errors, unless at least none of you are intending to.
Yeah, and it's like systems programming, which I've heard about systems programming, but never really like understood kind of what it is. But it's basically just running lower level code so that it runs a ton faster. And the way I kind of what intrigued me with Rust is that, as you said, like the memory management part, because like in the book, it's back there, the book we read, they start talking about like memory, memory management and stuff. And they say, like, for example, JavaScript has a garbage collector. So sometimes the garbage collector fires up and then it empties out all the hanging references or whatever you want to call them. And then you can do like manual memory management, which you do like in other even lower level languages. But then like the experience I had reading the book was like, okay, so you have JavaScript here. You don't have to think about memory management. And then I started reading about Rust. And then it was like, oh yeah, they're pretty good automatic memory management. And as further and further I got into the book, this slider kind of moved like this, because there is still a lot of, you have to think about this stuff. It's not like you don't have to think about memory management. It's just that it's way better than the common languages you do systems programming in.
It's not as far as C++ to the right.
Yeah, exactly.
And it's really nice that it gives this this safety net for you.
Yeah. But anyways, enough talk. Let's do some exercises. I'm not sure where I'm supposed to go first. Is this the maybe
the
this
exercises?
I guess I have to go to the actual exercises. I think this is the program.
You need to do
are we in variables? Variables 1? Yes. Oh, make me compile. So it says X not found in this scope. So I guess we have to talk about assigning variables then.
Well, then you can put a let before it.
Yes, let. This is how we assign variables in Rust. Woo! This is amazing. This is really nice, this exercise stuff.
How do you move to the next one?
Yeah, that's the big question.
Do you press enter or something?
In case this will try to verify the completion to run the exercises in the recommended order. Yeah, maybe I can just unknown command.
Oh, maybe
can keep working or jump. Oh, by removing I am. Oh, that's interesting. We remove this comment.
Okay, that's creative. That's creative. Okay, 2.
Yes.
You need to give it a type. Well, actually, you need to give it a value because it's not going to work, right? Or can you just give it? This is interesting. If you give it like a usize or something.
Yeah. So there are like in JavaScript you have just numbers, but in Rust, of course, being way low level, you have all these different things, like as you said, usize, and that's like I always forget this. What is usize? Because you have U8, U16, 32, 64, and then you have usize.
Usize is the amount of bits that you run it on. So if you run it on a 64-bit machine, and it's a U64.
Yes, exactly. It's dynamic based on the operating system. That's true. And then you have, so we can say, in this case, we can say like U8, for example. But we can also say I8, where U8 means not negative, it's unsigned, which means that it doesn't take negative numbers, only positive numbers. And then I8 is also negative numbers. And this is 8 bits, which means that you have from 0 to 256, I think.
Yeah, and for the I version, you have minus 127 to 128, I think. Or yeah.
That's interesting. Yeah.
Yeah, you have the cap of the yeah.
Yeah, exactly. Yeah, uninitialized, as you said. So it's not enough to just give it a type. You have to initialize it. So if we rather say 0, I believe it gives it. It gives it.
Oh yeah, I think you need to restart the if you do Command Shift P and then restart the extension host, because I think that
we
Rust
need
Analyzer just had an update. Yeah, you need to download it.
Oh. Yeah, and it does give like I32 as default, like whenever you just insert a number, like an integer. I think it does that. And then if you were to do like comma separated, you would actually get a floating. We can check that.
Yeah, it does. Yeah, it does make sense, because it's if they don't know what you want to do with it, then safer to allow negative numbers.
Enum structs. Oh, they do have structs and stuff. Yeah, that's good. Cool. Oh yeah. Yeah, because we're installing, like we have an extension which is pretty awesome, which is like just like the TypeScript extension, or I guess it's built into VS Code, where you get auto suggestions and type inference and everything.
Yeah,
it's really nice.
Oh, that's interesting. Maybe in the next file it will.
Rust Analyzer. There it is. Does it do anything now?
Do you? What if you hover over X? Doesn't run.
Maybe I'll have to restart it now. Now that I've installed. Indexing, Rust Analyzer.
Yeah, but oh yeah, indexing, that is new. It was just doing cargo check, the previous one.
Yep.
That's the oh yeah.
You have to reopen the file or something.
Maybe then you activate. I don't know.
Variables. What the hell?
I think I know. Oh no, I don't know. That's Rust Analyzer.
Rust Analyzer.
Maybe it doesn't work with these exercises because they are not in the main path of.
Oh yeah, that's true. Oh, that's pretty bad. Like I really want them to
show.
Yeah, maybe it needs to be part of the that kind of sucks.
Oh well.
Oh well, we'll do without the analyzer for now, and then we'll see. I guess we won't be able to go through all the exercises yet. Okay, we are done. All right. What's this? First argument. And what I really like about these exercises is that you go through the compiler. You go through compiler errors, and this is like typically in JavaScript how we do it. We go through console log statements and UI problems. That's kind of like how we verify stuff. But here you do it with the compiler, so you should really understand like the language of the compiler. That will help you a ton.
Yeah, it almost feels like the compiler is a really senior developer who's seen it all and is watching you.
Yeah, exactly.
Because in some cases, like if you're building something with multiple threads, then it will even help you with saying, okay, you need to do this, otherwise you will get race conditions in the future. It's really crazy how much it tries to cover.
Yeah, and like in Rust, everything is immutable, right? Or all the references, like when you assign a variable, this is a little bit confusing because you have references and you have values, and values can be immutable by themselves, or can everything be mutated? So like the number 3 here is thrown onto the stack, but then I can change that number, right? Yeah. So what they mean by immutability is that all assignments are immutable by default.
Yeah,
I think. So that's why we can't change this. We can't change this assignment. I might be using the wrong terms, but that's how I think about it at least. And if we want to be able to change it, we have to give it a mut keyword, mutation keyword. And now we're allowed to change it. So you have to explicitly say that you want to be able to change this this value. And I guess that's a good time to mention that, as we said in the beginning, that there's no garbage collector here. So the way it works is that whenever you assign a value inside a scope, which are these curly thingies, it means that that value will be valid until the end of the scope. So at the end of the scope, it drops everything that's been assigned inside that scope.
So X will be dropped.
Yeah. And like scopes can be like anything. You can even have a scope in here. So this is also valid. This assigns like 3 to X.
Yeah, but this is interesting because that 3 won't go out of scope after that block. So if you do that block statement again, normally the 3 would go out of scope after this block, but instead it gives now ownership of 3 to the top level block.
Yeah.
And so 3 is passed on to X. So now the main block has ownership. And now when the main block goes out of scope, then it will be cleaned up.
Yeah, exactly. And if I did, so we're kind of throwing stuff at this, but if I were to say this isn't valid. Like now 3 isn't actually returned from this block.
Yeah. 3 will be out of scope. Even it will be dropped from memory if
exactly.
Yeah. What if you run this one? What would it do?
So basically let's see what happens if I do this. So basically what it means, now we're getting a ton of errors. Probably like it's not assigned or something. And
the types also, because it returns nothing, the block.
Yeah, so you that's different from JavaScript. In JavaScript, you think about functions and returning values from functions. But in Rust, you think about scopes, and the last expression in a scope is what you return from that scope. So doing this, it's not an expression anymore, it's a statement. But doing this, it's an expression, and that's being returned from the scope. So you're gonna think a lot more about scopes in Rust, that's for sure. Anyways, I think we made that one work. All right, variables 4.
Okay.
Use of, okay.
Yeah, I need to make it compile. I think we need to initialize it.
Like this, yes.
Yeah. This is also interesting because in Rust, there is no concept of null. Or in JavaScript, the undefined or null. There's no concept of it in Rust. Everything is an object. But there is a concept of uninitialized variables. So you can keep a variable uninitialized and then assign it later. But the compiler will, like in the example, the compiler will check.
Yeah. And then it's this print thing we're using here. This is, it looks like a function call, and it kind of is, but because it has this exclamation mark here, it's actually a macro. And macros are something really, really cool. I read about them yesterday, Ives. And when you define a macro, it's kind of like a code mod. You have access to ASTs, and it's really, really cool, the API. So basically what it does is that when Rust compiles this code, it finds this macro and it replaces it with your implementation of the macro. So it's code replacement, basically. And the way it works is that you can, well, there are two types of macros. You have this kind of macro, which is a declarative replacement. And then you have a different kind of macro, which is a procedural replacement. So yeah, just to mention this is going way ahead, but when you have like a struct like this and you do, derive, is it derive debug or something? This is a procedural macro. This is also a macro. And what this does is it gives information to the macro about this struct so that you can use it. And you use a template language. You actually rewrite the code as a template where you can use information from the code and use it as template variables. Really, really cool how it works.
You like that?
I like that.
Yeah.
It's very accessible.
Yeah. What can you try one thing? If you have your mouse on println, and if you do Command Shift P, then your cursor and then Command Shift P, and then expand macro. I'm not sure if this works, but yeah, Rust analyzer expand macro recursively. It doesn't work. Okay.
Yeah, that really sucks. Maybe that could be a contribution to make the Rust analyzer work with this project.
Yeah, in the Rust playground, you can put this code, and then you can set an option to expand all macros, and then you can see actually what the macro writes. So then you can see the code with the macro expanded. That's really interesting.
That's super cool.
One thing is that C++ and C, they also have macros, although I'm not sure about C anyway, but those are not typed, so then you lose typing information. But with Rust, you still keep typing information with macros. It's really cool.
Yeah, it's pretty powerful stuff. So like the compiler has like 2 steps. So it runs through the macros first to kind of build all the code, and then it compiles all the code. So that's the way I understand it, at least. What the hell is happening here? Number, spell a number, and then we mutate it to something else, and then we're adding to it.
Yeah, the types don't match. Like,
yeah,
in TypeScript, for example, you can have 2 types to assign to a variable, but that's not possible with Rust. In Rust, you can only have one type. The immediate solution that you could do would be an enum or something to be able to assign two types. But yeah.
And I guess we need to mutate as well. Yeah, that's a good point. Woo! Amazing.
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 Oh, a const.
Oh, yes.
Yeah, this is interesting. Yeah, const are evaluated at compile time. So I think it cannot infer types because of that.
Huh.
I'm not sure. That's really interesting. I'm not why const needs to have types inferred. That's really interesting.
Why is it yelling?
I think you need to assign a type to it.
Oh, is that? Oh, but it wasn't that. Hey, Rust Analyzer.
Hey, welcome.
Welcome. Okay.
But it does say, no, this is not because it's compiled that it cannot invert types, because even the compiler is telling you, maybe you should make this type. So now I'm really curious. Why? Maybe it's a language.
But what's interesting here is that constants are considered actual constants. They are handwritten into the binary. Well, handwritten. They're actually part of the binary, the way I understand it. So you can't change them because they're actually in there. And then there's something else. What was that? Yeah, those like constants are the only ones that can be out of scope. Like they're global. They're not part of. So if we were to do this, I don't think this works. Or this works.
Why?
What was it? There was something about global constants, or maybe it's that constants are the only ones that can be global.
Did you know that you can put constants also on traits? And implementation of traits?
Oh.
That's really interesting. I found that really cool because there was a pattern that I saw that people used to down type, like they had like a request type and they wanted to turn it into a concrete struct. And they used the const on the trait to match it. I can show later. It's really interesting. It's a really interesting pattern.
Anyways, I guess we weren't able to really explain what this is.
Yeah, I Googled a bit and they said that normally Rust can infer types for you based on how you use them later. Like if you create a number like let number is 5 and then you give it to a function that accepts a U32, then it will know, okay, this has to be a U32. So based on how you use the variable later, it can infer its type.
Yeah,
but
it's not how you define it, it's how you use it. The way it infers the types. Yeah.
Exactly. So but with const, that's it cannot do that because you don't have direct, you don't even have to directly use it. So
yeah,
that's
I
why
guess maybe if I did let, would it give the same error here?
No, then it should be fine. Then it should infer that it should be an I32, I think.
Yeah. Yeah, interesting. Yeah, anyways. But yeah, so there's the typing thing. And there's something about constants are different. They are like part of the binary, something like that.
It's also interesting that they're now working on const fn, so you can actually write functions that are executed at compile time. That's also really cool. They have tests.
Oh, interesting. We can't see. Maybe we should make this a little bit more. There we are. People can see our faces. Oh.
They can't.
No, I forgot to put it up there. Okay, we can put ourselves over here. There we go. Anyways, what's this? If conditionals.
I think we should do not use another function call or additional variables. Okay, well,
The bigger
this is,
number.
yeah, this is probably, yeah, this, oh, you need to return the bigger number. Okay.
Oh, okay. So we can do like an if A is bigger than B.
Yeah, but without the brackets. It's a JavaScript.
Oh, sorry. Yeah, I forgot. Else. Oh, do I need to have this?
Yeah, I'm used to using. Yeah, this is it.
So this is kind of interesting again, because now we have, like at the end of this function, we have two scopes and both of them returns. Like we're at the end of the scope, which means it will return either of these. And then inside these scopes, we have a single expression, which means that this is what's being returned. Oh, that looks nicer. Yay!
We also ran the tests, so that's really cool. I really like that.
I love that you actually define your tests inside that. There's so many good opinions in Rust. Like there's no freaking packaged npm modules and package and like different ways of doing workspaces or monorepos. Everything's in here and everything's considered, and they have doing modules is more of a convention around files and directories, while in JavaScript there's just there's like a million ways to do things, so it's very refreshing to have something to
like cargo is especially the workspaces. It works really well.
Yeah,
I think in Rust in general, it's the kind of things that they take into the standards. It's a good community. Everything is behind RFC.
shit.
Lots of people work together.
Yeah. By the way, this I can try to explain this syntax. So this is called is it called attribute?
Yeah.
This is an attribute, and this attribute reflects like the configuration of the environment running. So this basically just says when the configuration is test, meaning when we're running tests, you should actually treat this code. And this code is a module. So in Rust, modules can be like a file can be a module, but you can also explicitly define a module within a file, which we do here called tests. And then this thing here is basically like an import statement we know from JavaScript. The only thing that's special here is that super basically just says move up one level, which means move up to this file module and expose everything from it. And that's how bigger gets into the scope of this module.
What is really interesting is that they in Rust with import statements, they don't use paths. That's what I found really interesting. That there's no. Yeah, it took a bit to understand it because I was so used to using paths, but
yeah, exactly. Yeah, because you basically just define your modules using directories and files, and then you can just use them. You just think about as you said, you don't explicitly write a path. You do this double colon thing, which separates like namespaces, and those namespaces are reflected in the file structure of the project. Cool. Feeling confident? Are you feeling confident, Ives?
Yes, I think Fizzifu.
What is the test?
Fizzifu.
Oh, Fizzifu. Are we supposed to just change it to bar?
No, but because there's also a buzz. So for fuzz, we need to return bar, and for anything else, we need to return buzz. So an else if statement, I think.
Oh, so we also need to check if it's us, right?
Is, yeah, yeah.
Oh, us. That means bar or
and that means
boss.
pause.
Yay!
Yay.
Got the skills. Yeah. So I guess what's interesting here is what we're doing here. This goes into the borrow and ownership system of REST, where we have defined on this function that the string you pass in here, we are not going to take ownership of it, and we're not going to mutate it. We don't want a string itself. We want a reference to a string because we're not going to do anything about it. And we want to let whatever passes a string into this function should still own that string and decide when it drops out of a scope or drops out of, or is cleaned up, is dropped. I guess that's the term. So I guess what we're saying here is that give me a reference of a string, and I will return a reference to a string, which is a little bit confusing here, I guess.
Yeah, that's the elephant in the room for Rust with the string types. Like if you define a string literal, then it will. This is about how heap and stack works, because in the stack you put memory values that you know the size of at compile time. In the heap, you put stuff where you don't know what the size is. If you create a string literal, which is this, the compiler can actually put that string into the stack because it will know its size. It knows its size. So that's why in this case, if you define a string literal, you get a reference to a string. You're not able to mutate it because it's it has a fixed size. If you want to be able to mutate it, you need to convert it to a real string. Kind of.
Yeah, exactly. So if I do this, it's actually, I'm automatically getting a reference to a string here.
Yeah, and that's like, this is an exception kind of. But you can do, if you put it after the string, you call the function toOwned, or you do string from, then you get a real string, not a reference that you have ownership of, and then you can actually make changes to it. Maybe this works too. I'm not sure. It's string and then from. That's the function name.
Oh, from, sorry.
Yeah. So now you will have a sizable string that's stored on the heap.
Yeah.
And you can resize it. You can add new characters to it. You can remove characters.
Exactly.
But it's using the heap will be slower than using the stack.
Yep. That's true. So I guess if you do, like, this is special syntax, like this is a string, or what should we call it? I don't know. It's like a string syntax, and that always gives you a reference to that string you're writing. Like that's just implicit. Was there like, what was the Rust playground? Is that the thing? I wonder if we can see, does this give you types and stuff?
Oh no.
Oh, it doesn't.
But you can do, to know the type, you can assign it a type, and then you can assign it a type like a wrong type, like an empty type.
Oh yeah.
And then the compiler will say, no, it should be this.
Yeah, exactly.
Yeah, so now it says found.
Exactly. So it should be a reference to, but this is really interesting.
Yeah, what you could do, can you get the code back? And if you now make that the type that you give a string, like a normal capitalized string.
Oh, like this?
Yeah. And what will the compiler now say? Now it will probably give some help. Yeah. Okay.
Yeah, toString. Yeah.
Yeah, and then you will also get it. There are so many ways to, in the end, convert a reference string to a sizable string.
And but yeah, this, like we just touched on the biggest thing you have to get into with Rust. It's understanding. You don't necessarily have to understand what is on the stack and what's on the heap. That's like even lower level in terms of optimizations. But you have to understand, when do I have a reference and when don't I have a reference? And when should I use a reference? And how do I do things like dereferencing? And I guess like the closest thing we get to this in JavaScript, and that's actually a mental transition. It's understanding that when you give a number to a function as an argument, you actually pass a copy of that number. Like you pass, you don't pass that by reference. And you don't really think about this at all. Like you think about variables in Rust differently. It's like, how should I explain that? It's like all variables in Rust references some point in memory, it being on the stack or it being in the heap. And then you can pass everything around. So the biggest thing is like if we have, I don't know. Okay, so you have some number, and then you call a function like some func, and you pass it, I guess this. You pass that number as well. Do I have to do this? Yeah. You pass that number to this function, and you allow it to mutate it. If this some func, I'm just pseudocoding here. If this does 5, now this changes to 5. That's the mind-bending thing compared to type JavaScript, is that when you pass a number to a function, you can't like reassign it outside the function again. It's like a copy. But in Rust, you actually pass a reference to the number in memory if you want to, because I'm passing it as a reference, a mutable reference here. But in JavaScript, we do pass things by reference, but it's implicit. So if you pass a variable that holds like an object or an array, it's actually a reference to that object or an array. But you rather think about it as entities in your runtime. You don't think about this it as something in the memory. It's kind of, yeah, at least that's how I think about it.
Mm-hmm. Yeah, except for numbers, it's a bit weird because numbers naturally copy themselves between.
Yeah. Okay, should we do one more?
Yeah, let's do one more.
Is this functions? Functions. There we go.
Okay, this one. Okay. This one will be pretty fast to do, I guess.
Yeah. So we basically have to create a function. And this is how we create functions.
Bloop.
Okay. But I get, and there's not much to say about that. Like, this is how you define functions.
Yeah.
Yeah, I guess that's it. Cool, but we're going into like way more trickier stuff down here. But yeah, okay, for next time, I'll try to get Rust Analyzer to work. And then, yeah, I'll read the section about constants again.
Yeah, it's really interesting. There's the other pattern I found also really cool. So that's also something to.
Yeah.
I can talk about it later.
Yeah, maybe you can start the next session by talking about the loop pattern, and then we can just use this as a backdrop to kind of figure out where are our knowledge holes in Rust, so that we know what we need to read up on.
Yeah.
Anyways, I guess that's it.
Yeah, sounds good.
Yeah, we'll just find some time later again. I guess this will be more of a not very planned, but when we find time, we can do like a stream. Maybe we can do a bit longer next time.
Yeah, sounds good.
Cool. I guess I'll talk to you later, Ives.
Yeah, I'll talk to you later, alligator.
Bye for now.
Bye.